Step outside tonight and look up. The stars are flickering, dancing, shimmering like tiny flames. Now find a planet, Jupiter, Venus, Saturn. They're up there right now. Look carefully. They're completely still. Same sky, same night. One blinks, one doesn't. Why? You've seen this your entire life and never questioned it. Tonight, that changes. This difference is not random. It is physics revealing itself in your night sky, every single night, completely in plain sight. And once you understand why, you will never look at a star or a planet the same way again. Welcome to Why. The answer starts with what happens to light during the last few milliseconds of its journey. After traveling for years through perfect space, it hits our atmosphere. Light from a star travels for years through the vacuum of space in a perfectly straight line. Nothing disturbs it. Then it hits Earth's atmosphere and everything changes. Our atmosphere is not a smooth, calm layer of air. It is a churning ocean of air pockets at different temperatures, different densities, constantly moving and swirling. Especially at night when warm ground meets cool high air. When starlight passes through these shifting air pockets, it bends. This is called refraction. And here is the key: stars are so impossibly far away that from Earth, they appear as a single point of light. Just one tiny beam. When that single beam bends in the atmosphere, even by a fraction, the entire star appears to jump, flicker, twinkle. Think of it like looking at tiles at the bottom of a swimming pool. The tiles are perfectly still, but the moving water bends the light, and the tiles appear to shimmer and dance. Our atmosphere does exactly the same thing to starlight. Now here is the key insight that explains everything. Planets don't twinkle not because their light is different, but because of their size in the sky. Stars are unimaginably far away. Even our closest star, Proxima Centauri, is 4.2 light-years distant. At that distance, no matter how enormous a star actually is, it appears as a single dimensionless point of light. One pixel, no width, no disk. Planets are completely different. Jupiter is 600 million kilometers away at its closest. That sounds far, but compared to stars, it is practically next door. Close enough that planets show a tiny disk in the sky, a shape with actual width. And here is why that changes everything. A star's light arrives as one beam. When the atmosphere bends it, the whole star jumps. You see twinkling. A planet's light arrives as thousands of beams from thousands of points across its disk. When the atmosphere bends some of those beams, the others compensate. They average out. The planet stays perfectly steady. It is like the difference between balancing on 1 foot versus standing on 2 feet. One point of contact, unstable. Many points, steady. Stars are on 1 foot. Planets are on 2. All night, every night. Here is something you can test tonight. Look at a bright star near the horizon and watch it carefully. It does not just flicker, it flashes different colors. Red, white, blue, rapidly. Why? This is called scintillation, the scientific name for twinkling. And the color changes reveal something extraordinary. Starlight contains all colors, the full spectrum from red to violet. Each color has a different wavelength. Red light has long, lazy waves. Blue light has short, rapid waves. And crucially, each wavelength bends by a slightly different amount when it passes through the atmosphere. So when turbulent air bends the starlight, it does not bend all colors equally. Red goes one direction, blue goes slightly another, violet even more. The atmosphere is splitting the star's colors apart in real time, like a prism, and sending them in slightly different directions. At any given moment, only some of those colors reach your eye. A millisecond later, the air shifts and different colors arrive. Your eye sees it as a rapid flash of red, then white, then blue. The next time you see a star changing colors, you are not just watching something beautiful. You are watching your atmosphere performing a live physics experiment, separating starlight into its spectrum, 10 kilometers above your head. Here is a practical superpower this video is giving you right now. After today, you will never confuse a planet with a star again. The rule is beautifully simple. If it twinkles, it is a star, too far away. Single point of light. Atmosphere bends it. If it shines steadily, it is a planet. Close enough to show a disk. Atmosphere cannot destabilize it. This works from any backyard, any rooftop, any dark beach. No telescope, no app, just your eyes. Venus is the brightest object in the night sky after the moon. An intensely steady, brilliant white light near the horizon at sunset or sunrise. People call it the evening star, but it never twinkles like a true star. Jupiter glows as a steady, warm cream gold light. Saturn, a softer, steady pale gold. Mars is unmistakable. A steady reddish-orange point that never flickers, its color coming from billions of tons of iron oxide dust on its surface. If you are ever unsure, just watch for 30 seconds. If it dances, star. If it holds perfectly still, planet. Every single time, there is one place where stars never twinkle at all, and it proves everything about why they twinkle here. In space, there is no atmosphere. Astronauts on the International Space Station look out their windows and see stars that are completely, perfectly still. No shimmer, no flicker, no dancing. Every star is a sharp, steady, unwavering point of light. This tells us everything. Twinkling is not a property of stars. It is a property of our atmosphere. Stars have been accused of twinkling for thousands of years. Ancient cultures saw them as living, breathing things. Poets wrote about their flickering light. Twinkle, twinkle, little star has been sung for 2 centuries. But the stars were never twinkling. We were. Our atmosphere was. Every twinkle you have ever seen in your life was Earth's atmosphere. This invisible ocean wrapped around our world, moving and breathing and bending light in the last millisecond of a journey that took years. The star sent perfect, still light. We added the sparkle. So, why do stars twinkle but planets don't? Because stars are so unimaginably far away that they appear as single dimensionless points of light. When that single beam passes through Earth's churning atmosphere, even the tiniest bend sends the whole point jumping. Your eye sees twinkling because planets are close enough to show a disk. Their light arrives from thousands of points across that disk. When the atmosphere bends some beams, others compensate. The planet stays steady because twinkling is not a property of stars. It is a property of our atmosphere, an invisible ocean of swirling air pockets, constantly bending and redirecting light in the final milliseconds of its journey. And because the light entering your eye right now from that twinkling star may have left its source hundreds of years ago, traveling in a perfect straight line through empty space, only to tumble through our turbulent air in its final moments and arrive at your eye as a shimmer. Thousands of years of perfect travel, one moment of chaos, and then we live under a miracle of physics, and it performs for free every single night. You've been looking at the night sky your whole life, and now you see it differently. Stars twinkle because they are impossibly far away, single points at the mercy of our atmosphere. Planets don't twinkle because they are close enough to show a disk, stable, steady, unwavering. Every twinkle was never the star. It was always Earth. Next week on Why, we ask something you have felt your entire life but never truly questioned. Why does gravity exist? Not just what it does. Everyone knows it pulls things down. But why does it exist at all? Why does mass bend space? Why is there a force holding the entire universe together that nobody fully understands? That answer will change how you feel about standing on the ground. If tonight's sky looks different to you, subscribe to Why. Share it with someone who deserves to see the stars differently too.